Hey guys, I'm back with Uncertainties, a geometrical application. Okay, so in this problem, what approximately is the percent uncertainty in the volume of a spherical basketball, and not the rectangular kind, careful there guys, whose radius is r equals 11.72 plus or minus 0.09 centimeters. Okay, so at this point, I'm sure you know how to calculate the volume of a sphere. Okay, it's 4/3 pi r cubed. Okay, in this case though, we've got that uncertainty there, and it's not so straightforward as simply cubing that uncertainty. Okay, we first have to look at the ranges that the radius can be. Okay, so the radius can have a minimum value of 11.72 minus 0.09, and it can have a maximum range of 11.72 plus 0.09. Okay, so the max value can be 11.81 centimeters, and the minimum value can be 11.63 centimeters. Okay. Now, so there are your max and min values. All right, so the volume of a sphere is given by 4/3 pi r cubed, and at this point you really should have that memorized. Okay, if you are taking AP Physics, they should give you the equation, but nonetheless, okay, after you do a lot of problems, you're going to inherently memorize it. Okay, so now we need to determine the minimum and maximum volumes. Okay, obviously based on the minimum and maximum radii. Okay, so V min is equal to 4/3 pi r min cubed. Okay, and same with V max. V max is equal to 4/3 pi r max cubed. Okay, so let's move that up a bit. Okay. So the next step, let's plug in our values. So for r min, pi, our minimum value was 11.63 centimeters. Make sure you include those units. Okay, and for max, 4/3 pi, 11.81 centimeters, also cubed. Okay, if you calculate this value, okay, you punch that in your calculator, you're going to get 6589.125106 centimeters cubed. And for the max, you are going to get 6899.828595 centimeters cubed. Okay, so let's just do a line there down the middle to separate the two. Okay, so now here's the thing. The uncertainty in the volume is half the difference between these extreme values. Okay, let me write that down for you. The uncertainty in the volume is half the difference between these extreme values. Okay, so remember, whenever you use a measuring instrument, it's half of the smallest denomination. Here we've got two ranges of volumes, so you take half of the smallest value, or half of the value of the difference between those two numbers. Okay, so let's keep going. We've got the min, we've got the max volume. Okay, so the uncertainty in the volume. Now here is where we can start introducing some notation, okay? Volume we expressed as V. Whenever you have uncertainty, you can express it as the symbol delta with the variable in front. Okay, so delta V would be the uncertainty in the volume V. Okay, so we said it's half the difference, so half 6899.828595 centimeters cubed minus 658.9.125106 centimeters cubed. Okay. Simplifying the expression in brackets, you're going to get 310.703489 centimeters cubed. Okay, keep those units. When you divide that in half, you're going to end up with 155.3517445 centimeter cubed. Now obviously I'm keeping a lot of decimal places. You can keep 4 if you'd like, generally speaking, without a more rigorous explanation and definition of uncertainties, okay, what you want to do is keep as many decimal places as you can, and you can use the number of sig figs in the final point. Okay. So now remember the original question. Okay, the original question stated that this is our measurement. Okay, and it originally had 4 sig figs. Okay, so because that had 4 sig figs, we have to give our value to 4 sig figs. Okay. So if we round this to 4, we're going to get 155. Now the 5 rounds the 3 up because this is greater than the halfway point. Okay, centimeters cubed. Okay, so the uncertainty in the volume is this value. Okay, remember we found the actual values for the volume. Remember, you've got V min and you've got V max. Okay, so therefore percent uncertainty is delta V over the volume specified. Okay, so the volume ranges were simply done to give us an idea of the uncertainty, but in order to find the actual percent uncertainty, we need the specified volume, right? So using that value of 11.72. Okay, so, and of course we have to multiply that by 100. So if we plug that in, we're going to get 155.4. Okay. 155.4 centimeters cubed divided by 4/3 pi. The radius that was given in the problem is 11.72 centimeters cubed. So you can see there the centimeter cubes are going to cancel out. Okay, and that value gets multiplied by 100. Okay. So if you continue this calculation, you're going to end up with 155 centimeters cubed divided by 6743.2839 centimeters cubed. Those cancel out because you got the same units on top and on bottom, times 100. Okay. Now, if you round this value to 3 sig figs, you're going to end up with 6,740. Okay, in this case, we need 4, so you can keep it as 6743. Okay, so let's go ahead and divide those numbers. 155 divided by 6743.2839. You're going to end up with the number, you multiply that with 100, and you're going to get 2.2985. Okay, actually that 5 should round to a 6. Okay, that's after you multiply by 100, which rounds off to approximately 2.3%. Now, again, remember in the original question, it says, what approximately? Okay, so whenever it says approximately, you're looking for an integer value for the percent. Okay, so in fact, this 2.3%, we're going to round to 2%. Okay, so for a rough estimate, okay, only round numbers are needed. Okay, so that's it for this video, guys. If you enjoyed it, be sure to give that like button a click and subscribe to this channel so you never miss a video from me.